Okay, this video covers the second part of our notes on complex numbers and imaginary numbers. And I think what's important to remember as we're going through here, the goal of Algebra 1, the Algebra 2 is to do operations with complex numbers. And then once you get into pre-calc, you'll apply those operations to problems, and then you can advance your skills further. So we're learning the beginning steps so you can put it into more challenging problems in the future. All right, so last time we discovered that the square root of -1 was I. Well, what if I know I equals the square root of -1, what if I squared both sides? Well, then the left would be I squared, and if you square a radical, it cancels it, you get -1. So we need to remember today that when we get I squared is the same thing as -1. All right, so let's look at our notes. For number 1, we need to find each product, which means that we're going to multiply. Notice that these numbers are right next to the parentheses, so that's how we know it's multiplying, or there's two parentheses touching, unlike what we did last time where there was pluses and minus inside the parentheses. Okay, so in this first one, 5 times 12 will give us 60. I times I is I squared, but I squared is -1, so this is really -1 times 60, which is -60. All right, number 2, we're going to distribute. 3i times -5 is -15i, but 3i times 4 is 12i squared. But I squared is -1, and -1 times 12 is -12. So this is my final answer. You are not going to have I squared in your final answer. So now I'm going to take -2 times 7, which would be -14i. -2 times -6 is +12. I times I is I squared. But again, I squared is -1. So it changes the sign, so I now have -12. And that's my final answer. Okay, number 4. Now we're going to multiply a binomial times a binomial. So 7 times 7 is 49. 7 times 4i is 28i. -4i times -7 is -28i. And -4i times 4i is -16i squared. Well, in the middle, -28, they cancel out. So I get 49. And then remember, I squared is -1, so -16 times -1 is +16. And now I can combine those together, giving me 65. All right, number 5. Again, I'm going to multiply. I'm going to FOIL, distribute, whatever you're going to call. -5 times -5 is 25. -5 times -6i is +30i. And here I get -30i and then +36. Well, the i's cancel out, 36i squared. So the i's cancel out in the middle, so I get 25. And then 36i squared, well, I squared is -1, so it really should be -36. And 25 minus 36 would be 11. Oh, -11. All right, let's try this again on number 6. -3i times 3i is -i squared. -3i times 8 is going to be -24i. Then I get +24i, and then +64. The middle terms cancel out. I squared is -1, so -1 times -9 is +9, plus 64, which would equal 73. Okay. So, we need to figure out now what a complex conjugate is. A complex conjugate is a complex number. Oops. Complex number where the real number is the same and the imaginary number is the opposite. Okay, so what am I talking about? Well, let's look at this one. If we have 3 plus 7i, the complex conjugate, well, the real number is 3. It's going to stay the same. The imaginary number is going to change sign, 7i. Try one more. If I have negative 4 minus 2i, the complex conjugate, the real I stays the same, negative 4. The imaginary changes sign, so it's plus 2i. Now, notice on 4, 5, and 6, all of these up here were complex conjugates. And when I multiplied by the complex conjugate, the middle number always cancels out. So only when we have the complex conjugate do we have a little shortcut. So let me look at this first one. 7 minus 4i, whoops, totally wrote that wrong, times 7 plus 4i. We have a little shortcut because we know the middle term, only when it's a complex conjugate, we know that the middle term is going to cross out. So my shortcut is I'm going to take 7 times 7, which is 49. Negative 4 times 4 is negative 16. I squared is negative 1, so it's really positive 16. And then I can add those together and get the 65 and don't have to do all the work. Remembering this is going to help us for this next thing. We need to write each quotient, which means division problem, in the form of a plus bi. So our goal is to split this into 2 fractions. So again, keep in mind, we're just learning operations and skills so that later on in more advanced classes, you can put this to use and it'll be more helpful to you. So to do that, we have to multiply the bottom times the complex conjugate. Well, the complex conjugate of 2 minus 6i would be 2 plus 6i. Well, to keep the fraction balanced, whatever I do to the bottom, I have to do to the top. So when I simplify this, on the top, 80 times 2 gives me 160, plus 6 times 80 is 480, so I get 480i, all over, now on the bottom, remember our shortcut. You're going to multiply the first 2 numbers. 2 times 2 is 4. Negative 6i times negative 6i is negative 36i squared. But I squared is negative 1, so it changes the sign. So we have plus 36. Okay, now I'm going to rewrite this. So I've got 160 plus 480i all over 4 plus 36 is 40. Once I get it, so there's just one solid number in the numerator, then I can rewrite it. So that would be 160 over 40 plus 480i over 40. But before we consider, and now see how it's split into 2 terms? Before we can consider this our final answer, we need to reduce it. So the zeros cancel out. 16 divided by 4 is 4. Plus, the zeros cancel out, 48 divided by 4 is 12i, and that's my final answer. Okay, let's try this again on number 2. I need to multiply the top and bottom by the complex conjugate of the bottom. So that means I'm going to keep the real number the same, negative 1, change the sign on the imaginary. So on the top, now I'm multiplying a binomial times a binomial. This is going to be a little bit more work. I cannot use my shortcut on the top because my top is not the complex conjugate. I've got to multiply this all out. So 4 times negative 1 is negative 4. 4 times 2i is negative 8i. Negative 3i times negative 1 is positive 3i. And negative 3i times negative 2 is positive 6i squared. On the bottom, I can now use my shortcut because they're the conjugates. Multiply the first 2. Negative 1 times 1 is 1. On the bottom, 2i times negative 2i would be negative 4i squared. But I squared is negative 1, so it's going to really turn out to be multiply 4 times negative 1, or negative 4 times negative 1, which would be positive 4. Now I need to rewrite this, simplifying it. So on the top, I get negative 4, and then negative 8 and 3 would be negative 5i, and then positive 6i squared would be negative 6, because I squared is negative 1, all over 5. Simplify that again. That gives me negative 10 minus 5i over 5. Once it's simplified, I can write this into two fractions. So I have negative 10 over 5 minus 5i over 5. Well, negative 10 over 5 is negative 2 minus I, and there's my answer. Okay, on number 3. On number 3, on the bottom, we don't really have the conjugate for it, because we can't really create that because we don't have a plus and a minus. But if we think about it, if the 4i really could be 0 plus 4i, right? So the complex conjugate, the 0 stays the same, and then we change the sign of the imaginary number, which is 4i. But 0 minus 4i, isn't that just negative 4i? So to make this work, we're going to multiply the top and the bottom by negative 4i. So on the top, 5 times negative 4i is negative 20i. 2i times negative 4i is negative 8i. And on the bottom, negative 4 times 4 is negative 16 times I squared, which is negative 1. So negative 16 times negative 1 is positive 16. On the top, I need to simplify this further. Negative 20i minus 8i. Oh, shoot. This is not 8i. This is 8i squared. Okay, so that gives me, I apologize, that gives me negative 20i, negative 8i squared. Well, I squared is negative 1, so now it becomes positive 8 over 16. All right, now that it's simplified, I can write this into two fractions. So negative 20i over 16 plus 8 over 16. And now we need to simplify. I can divide these both by 4, so I get negative 5i over 4 plus 1/2. So you will sometimes get them as fractions. All right, let's try this again on the next one. The complex conjugate of this is going to be real number the same, opposite sign on the imaginary. On the top, they are not complex conjugates, so I have to multiply the whole thing out. 3 times 4 is 12, plus 9i, minus 8i, minus 6i squared. On the bottom, because they're conjugates, I can use a shortcut. 4 times 4 is 16. Negative 3i times 3i is negative 9i squared, which is the same thing as positive 9. Now I need to simplify. Let's see if we can simplify a little bit more together. Negative 6i squared is really positive 6, right? So now when I go to simplify this, 12 plus 6 is 18. On the bottom, or excuse me, continuing on the top, 9i minus 8i is, oh goodness, would be plus I. And on the bottom, 16 plus 9 would be 25. Now I'm going to rewrite this into my two fractions. So I have 18 over 25 plus I over 25. Neither one reduces. That's my final answer. Okay, we can also use this in factoring, but we have to review some old factoring. This pattern is difference of squares, which is a squared minus b squared, and that factors to a plus b, a minus b. Okay, so we're doing this, it's a binomial, there's a minus sign. I can take the square root of both. Square, I can't write what I'm thinking. The square root of x squared is x. Square root of 49 is 7. One's plus, one's minus. We're done. Now, on number 2, doesn't work quite that easily because it's a binomial. We don't have a minus sign. We can't take the square root. However, when we factor, we cannot start factoring with a leading coefficient of negative. So I'm going to look to see if I have greatest common factor. And I do. It's 2, but I'm going to take out a negative 2. And negative 2x squared divided by negative 2 is x squared. 50 divided by negative 2 is negative 25. Now it's the difference of squares, and I can rewrite this as x plus 5, x minus 5. Well, now that we've reviewed that pattern, now we have a new pattern. Now we can do the sum of two squares, which we weren't able to do before because we have the imaginary number now. So to factor this one, it's a binomial. I can take the square root of both, and it's got a plus sign. So now I'm going to have an x and an x. And now square root of 36 is 6, but because there's a plus sign, we're going to do plus 6i and minus 6i. Let's try this again. On number 2, I have a binomial, I have a plus sign, I can take the square root of everything, so it fits my pattern. Square root of 4x squared is 2x. Square root of 81 is 9, but to make the pattern work with a plus sign, we need to have an I in there. So we have plus and minus. Okay, the last one, can't do the, you're looking at it's a binomial, there's a plus sign, but I can't take the square root. But remember, just like we had on number 2 up above here, you can always look for a greatest common factor, and this one has one. It's 3. So I'm going to take out the 3, and I get x squared plus 16. Now that I've done that, it fits my pattern. And now I've got x and x, 4i and 4i, one's plus, one's minus. All right, what we did on 1 through 3 was factor, but these problems all have an equal sign in them. So now we're not factoring, now we're solving. So our final answer is not parentheses, but x equals something. So on this one, to solve by factoring, first step, set it equal to 0. It is. It fits my sum of squares pattern. So this is going to factor to x plus 5i and x minus 5i equals 0. That's step 2. Step 3, write equations and solve. So x plus 5i equals 0 and x minus 5i equals 0. So to solve, I'm subtracting 5i. So I get x equals negative 5i. Over here, I would have to add 5i. So I get x equals positive 5i. And those are my two equations, or two answers. Now, do you have to write all this down? No, but it's the first time we did it with I, so I want to make sure you saw how it worked. Number 2, it's set equal to 0, so now I'm going to factor. This fits my new pattern, sum of squares, so I'm going to go straight to my 2 parentheses. Square root of 9x squared is 3x. Square root of 49 is 7, but to make the pattern work with a plus sign, I need to add an I. One's a plus, one's a minus. Now, if you're not sure about this one, if we set it equal to 0, we'd have to subtract 7i from both sides. So we get 3x equals negative 7i. Divide by 3, so x equals negative 7i over 3, which means this one over here, x would equal positive 7i over 3. All right, let's try the next one. Number 3. It's not set equal to 0, so I got to switch it. So I get x squared plus 100 equals 0. Now I can factor. It fits my new pattern. So I have x plus 10i, x minus 10i. So x equals negative 10i and positive 10i. Number 4. I get set it equal to 0, so I get 25x squared plus 9 equals 0. It fits my new pattern. So I have 5x and 5x. One's 3, one's negative 3. But I have to add the I when it's a plus. So when I solve, I'm going to subtract 3i and divide by 3. So I have negative 3i over 5. And this one, add the 3i. So I have 3i over 5. Last one. It's set equal to 0, but I got to factor it. Okay? So I know I have an x and an x. Well, the square root of 1/9, it's like the square root of 1 over the square root of 9. Well, square root of 1 is 1, square root of 9 is 3, so square root is just 1/3. 1's a plus, 1's a minus. So when I solve, x equals negative 1/3 I, and x equals positive 1/3 I. And no, you didn't need to write the plus sign. I just did accidentally. That's it.